How you doing?
The stacker and the reclaimer, right?
Yes.
Okay.
Not really. I'll call you back. All the other side where we came from, or from this part, is our commercial and the plant. But from this other section now, going up here, to the left is our sintering plant. We are going straight, sir.
Okay.
To the left is sintering plant.
Yeah.
So sintering plant, you see, is very wide. Imagine where we turned from that time. Up to this part is called sintering plant.
That's it.
Because it has different sections that works on different raw materials.
Okay.
Dolomite, you have a section for dolomite, you're turning right. He has a section, you can see sintering plant, that is what's on that signboard.
Okay,
so from this going down to the end of the road, sintering plant. So you have a section that processes dolomite, you have a section that processes limestone, you have a section that processes iron ore. Up the current has to be stepped down. 110.
Okay.
So these are our MSDs 1 and 2.
Okay.
Main substation.
Okay.
We used to step down the current
Yes.
of the electricity that is produced before is now distributed to the different plants where they are needed.
Okay.
So that is MSDs 1 and 2. The building in front, this plant now is our lime calcination plant.
Okay.
Lime calcination plant handles the processing of limestone into lime.
Yes.
Limestone is the raw material that is gotten.
Yes.
When it's brought here, it is brought to this and then processed into lime.
Yes.
Lime is used as a fluxing agent. I told you earlier. This is built in a eco-friendly way, in such a way that because limestone, when you crush limestone, there's a lot of dust. But we have an electromagnetic dust catcher here.
Okay.
So that electromagnetic dust catcher catches the dust to ensure that it keeps the environment serene.
Okay.
So that the staffs here are not affected by the dust.
That's great.
So that is lime calcination plant.
Okay.
Right.
Okay. Is it the same place they call aluminum silicate?
No. I'll show you aluminum silicate.
Okay.
I'll show you aluminum silicate. Look at that plant in front.
Yeah.
It's aluminum silicate. When we get there, I'll show you.
Okay.
I'm turning this way.
All right.
So we have the steel plant is divided into 3 sections. We have the primary plants.
Yes.
We have the secondary plants.
Yes.
And we have the auxiliary plants.
Yes.
The auxiliary plant supports the primary and the secondary plant in their production. Secondary plant are the finishing plants. We have the billet mill, we have the wired rod mill, we have light section mill, and we have medium section and structural mill. Go straight.
Okay.
From here like this are our secondary plants.
Okay.
This one we have in front of us is our billet mill. Billet mill is where blooms are converted into billets.
Okay.
Billets are used as raw materials for wired rod mill and light section mill.
Okay.
So when these blooms get here,
Yeah.
they are converted into billets.
Which
Let's
way?
go straight.
Okay.
We'll enter in from the other side. These blooms, take note, blooms are raw finished product from our steel making shop. Blooms are used in our steel making shop. Let's go straight.
Okay.
They're also used in one of our secondary shop, which is medium section and structural mill. Blooms is what is used there.
Yes.
But for light section mill and wired rod mill, it is billet that is used. So those blooms have to be converted to what we call billet. We are turning here.
Okay.
Sir, without blooms, can you process with your work?
No. It's stage by stage. That's why it's integrated steel plant.
Are we going in?
Yes, no, we are going straight.
Okay.
We enter from the other gate. So this is our billet mill on this side. You can see it, billet mill. On the other side, this is the back view of our steel making shop. So when the pig iron gets here, there's a section here called continuous casting section that casts those liquid iron into blooms. You understand? These blooms are now channeled. Let's go. We enter from that. Okay. Are now channeled down here and used as raw materials for the production of billets. Some of it is channeled to medium section and structural mill, where they are used as their own raw material. So just drive in. You can see all these are brand new vehicles that were left by the Russians. You can see them. They're supposed to serve this place.
Okay. So which shop is this?
This is billet mill.
Okay.
This is billet mill. You can stop here.
Okay.
We will not come down, but let me just give you brief.
Okay. No, can we stay in the car and have it talk?
You can, but
Okay.
I'll stand on the other side.
Okay. Are you enjoying this?
Yes.
Are you seeing all this?
Yes. Sir.
So gigantic, right?
So this
Okay.
big plant you see is called our billet meal. Say
Okay.
billet meal.
Billet meal.
Billet meal.
Billet meal.
So when blooms, these are blooms.
Can you see that?
These are blooms. These are brought from our steel making shop
Okay.
as the raw material that's needed in this our plant.
Okay.
These blooms you see, each of them are 4 tons.
Yeah.
4 tons.
Keep quiet and listen. Yeah.
4 tons is
4 tons.
Yes, 4 tons.
Yes.
That is as heavy as it's equal to like 200 bags of cement.
That's serious.
Each of this
Yep.
is equal to. So Dangote truck cannot carry above, let's say, last one has to 4. If you put more than 4, you can't move it.
Yes.
3, 4, thereabouts.
That's
What
serious.
A whole Dangote truck
Can carry.
can carry. So, but the question now is, how are they being moved here?
That's the question I was going to ask you. The cranes.
Our electromagnetic crane.
Good.
You can see
Yes.
electromagnetic crane works with electric. It's a magnet that works with electric. So when
Yes.
it's turned on,
Yes.
when there's current,
Yes.
you can see the 2 blocks under.
Yes. Oh,
As a magnet.
yes.
It's an electromagnet. 2 of them are electromagnet. You have 2 of them. So once current comes here, and this crane is brought here, these blooms, as heavy as it is, will
Yes.
be magneted.
Yes. And taken up.
Yes, taken up here.
Yes.
And that's how it's carried. But it has one side precaution.
Yes.
During operation, nobody's supposed to stay under it.
No, of course.
If there is
There's failure in the
failure of
power. It will
drop.
drop.
You understand?
Yes.
But because this our Russian men, they know the kind of people they are dealing with.
Yes.
They now created this fork
Okay, fact.
see the effect?
Yes, yes. Okay, as a
So,
safety.
as a safety
guard.
precaution.
As a
Yes,
safety guard.
safety guard. So as soon as he picks it up, the fork now comes under.
Comes under.
So in case there's
Yes. Yes, because
shortage
the
in
power
light or
failure.
outage,
Yes.
it doesn't fall to the ground.
That's safety. That's safety
That's
incorporated into
safety,
design.
Yes. So
Wow.
the electromagnetic crane is responsible for moving the blooms to the different sections where they are converted into billets.
Wow.
Moved over there. We have our arc furnaces down there. Arc furnaces that are used to smelt
Yeah.
blooms, you see,
Yep.
into billets. We have our these pipes that links
Yes.
in. We have our natural gas. It's used to power our arc furnaces. We have air combustion that also used to power it. We have water, which I told you is used for cooling and all that.
Wow. Great. Thank you
That's
very
why,
much.
yeah. And then you have fuel that
Thank you
runs
very
through.
much. Wow.
So that is.
Yes. You said?
Afternoon, sir. Yes, sir.
Yeah. Who's asking the question? Yes. Ask the question.
What are billets?
What are billets? Yes.
So billets are the raw materials that are used in our wire draw mill and our light section mill. They are gotten from blooms. This one I just showed you. You see this plant, this house, this factory that we are inside now is the factory that is responsible for the creation of billets from blooms.
From blooms.
You understand me? So that's what they do here. So
Okay.
billets are created
Yes.
here.
Next question.
Next question.
Why is it that what?
Why is it dark?
Why is it that?
Well, of course, that
Because
it's commonsensical because there are sheets covering the on the roof now, covering the sunlight.
Shit.
Sheets. That is
Aluminium.
aluminium sheet. These things you are seeing,
Oh.
roof, shielding you from sunlight. The light is coming from sun. Okay. Yes.
So all from here is the other side is light section mill.
Okay. Which
So,
side? Light
this side,
section.
this side.
Okay.
From
That is those thin rods, right?
yes.
8 mm, 12 mm.
Yes, that's
16
where they are
mm.
gotten from. Light section mill.
Yeah.
There is where production of all the
Rods.
normal rods.
Yes.
Uncle,
Yes.
when was this built?
When was it built? Question. When was the steel plant built?
The steel plant was not built in a year. It was built during the administration of the late Shehu Shagari.
He started during his administration. What year was that, sir?
So it was built from the year 1971, but
Really?
it was commissioned in 1990. So you can see all this from here going down is
71. Is it 71 or 81, sir?
the
ground lane.
the ground lane.
Yes.
No, 71.
71. That's
91.
serious.
Yeah, it's 71.
So, sir, does that mean that it's only Shehu Shagari that built the road?
Yes, it's only Shehu Shagari, and he built it within 3 years of his administration before he was overthrown. Before he was overthrown. So you can see this light section mill where all our bars are produced.
Okay.
Angle bars and all that. This is a wire rod mill on the other hand, the other side, where we get our wired products.
Wow. Yes, Ikma. What's the meaning of what? Bag? I don't get that. You mean the bag?
Bars.
Bars.
Bars. Yes, the bars are like the one we showed you, the finished product we showed you during our class at the admin building. This is where they are made from. They are iron bars, you understand? They are gotten from.
They are rods.
They are rods,
They use them in building reinforcement, concrete reinforcement
bars.
to build your gutters, your culvert, your pillars in the building, and so many other things.
Straight. To our secondary plant was, which was our billet plant. We have auxiliary plant that supports our primary plants and our secondary plant in their production. So all the forge and fabrication, foundry, machine and tool shops, equipment repair shop, pattern making shops, rubberizing workshop, all they are just auxiliary plants.
Yeah.
They are
Which way, sir?
They are straight. Their function is to support.
Yes.
So both support carry out the maintenance and then for the repairs of the parts, machine parts and all that. That's what these are our wagon tipplers. They are used to carry heavy rods round the plant site.
Okay.
So you can see those are the wagons. The train head. Oh, sir, stop. I want them to see this. It's very important. But you can just drive closer. So can you see them?
This is the engine that
This
drives
is the engine
what?
that drives the
train,
wagons.
the
round,
wagons.
You can see it. We have 110 of them
Can you see that?
inside this place. 110 of them.
110
Yes.
Of-
This head.
of this engine.
This engine, yes.
110.
110.
God.
Hello. Good afternoon. So you can see them. Their job is to drive, and they can move both ways.
They can move both ways.
They can move both ways. So you can see they can anchor any of the wagon from any
Yes.
side, both this side and the other side, and then move. So that
So
is
they are called locomotive, right?
locomotive trains. Yes.
Yes. Something. Who said they are what? They are what?
They're just wasting.
They are wasting, right?
Nobody's working, right?
And they are still functional, oh, as you see all of them. They
Yes.
still carry out.
That is why that's why we brought you here, so that you
Routine
can know what's going on, the amount of wastage going on here, so that you can study hard, and God's willing, in the future you become someone that is relevant enough to put them to use. Okay.
So that is our wagon ticket.
Yeah.
Aluminum silicate refractory plants. They make
Yes.
refractory bricks.
Yes.
Turn it this way.
Aluminum silicate.
Yes. This plant makes use of clay
Yes.
to make refractory bricks.
Yes.
The refractory bricks are also used to line the internal part of our furnaces,
Yeah.
our arc furnace, to
Yeah.
ensure that the heat
Yes.
from the furnace does not spoil the
Right,
wood.
right.
No, we are going straight. This is our equipment storage building,
Okay.
where we store most of our equipment. The other one is our pattern making shop. Pattern making shop is very important. It supports forge and fabrication shop because they make the molds by which forge jobs are carried out. So that's the job here.
At least you can still see people working.
You can see engineers on site.
They are working.
They are doing their work. So this is our pattern making shop where they make use of wood. Their raw material here is wood to
Yes.
form different molds on different patterns,
Yes.
which they then send to foundry, which is the one down behind,
Okay.
where casting is done.
Okay.
This is our equipment repair shop.
Yes. Uh-huh.
Test.
Okay.
All our transformers and all that
Okay.
are repaired
Which way?
here. We are going straight.
Okay.
So they are the
Good
first.
afternoon,
A
sir.
question, yes. What's the question?
What is a billion plant?
What is a what? Pardon?
What did you say?
What is a building plant?
Is it building plant?
I didn't get that question.
Okay, then we'll move on. We'll move on.
Move
The question
on.
is not clear.
Administrative building for each of the plants,
Okay.
Okay, so just so this one is the one for this plant, forge and fabrication.
Yes.
Forge and fabrication, they make use of blooms also.
Okay.
So this is one of the places where blooms are brought. They are used where you fabricate different type of machine parts.
Okay.
So we have our arc furnaces here also, where they use to smelt this iron and make all these parts, or join the different irons together
Okay.
to forge different this thing. Then, very importantly, we have our machine and tool shop, where jobs from forge and fabrication and foundry shop are brought here for finishing,
Yes.
machining, to get the accurate and precise measurement of those.
Which way? This is what? Which shop is this now?
This is machine and tool shops.
Is this the engineering works and service?
Yes.
Okay.
This is part of it.
Okay.
But it's like one of the major, because this is where.
Okay, you can go on, sir.
Okay, so welcome to machine and tool shop.
Welcome.
Okay, so welcome to machine and tool shop. Come over to this side so you can just see. So here we do all type of machining, and we do a lot of jobs, create a lot of machine parts to support our primary plant and our secondary plant. Just as I told you, as you can see, this is just a showcase of some of our jobs that we have finished here.
You mean these parts are actually
They
produced
were all
here?
made yes.
They were all made here?
Yes.
That's in,
We work on different times. Don't go over. Don't go over. So as you can see them, so eccentric gears, you can see spurs and all that. They are finished jobs. So as we go around, you will just see.
so the experts who work here are
most of
mechanical engineers, right?
Yes, they are. Yeah, I think so.
Production, mechanical engineer. I think I'm aware of that. Production as an aspect of mechanical engineering.
So you can see all these machines. Different type of milling. We have the vertical ones, we have the horizontal ones.
Wow.
All these are manual. So we have this. We have three sections of this plant or machine.
Okay.
This is the light section. The next section is the heavy section, where
Okay.
you have machines that do heavy duty jobs.
Yeah.
Then the other section inside is the heat treatment section, where they do all the treatment of the materials.
Be careful.
They do treatment of the materials to harden. Question. Which of them? This is more like a circuit box. More like a circuit box to control.
What are the females that want to be engineers? Khadija and who? I want to be engineers. Okay, that's great. And Toib. Okay, that's great.
So you have to study very well so I can come and help us to.
So it's a milling machine, right?
Yes.
Everybody say milling machine.
Milling machine.
What are they used for, sir, please? Milling of. Okay, for milling operations. Okay. So produce flat surface. Okay.
So I think we can do that.
Okay. Say thank you very much, sir.